you're up. Hope you're ready for the dawn of a new day in this damp tin can that we're calling home. Week 3 already, huh? Seems like just yesterday you were fumbling over the basics. Look at you now. Power, light, a snazzy RGB battery indicator. All pretty impressive, I must say. This week we're shifting gears. Enough with the basic survival needs. It's time we brought this old ship back to life. Our goal is to fix up that control panel, whose appearance looks as if a Martian tried to play tic-tac-toe on it. To start us off, we've got a new tool to familiarize ourselves with. A 4x4 keypad. I know, you must be thrilled. Do try not to let its looks intimidate you. That's 16 whole buttons of potential inputs at our fingertips. Alongside our new hardware, we've got a new concept to grasp. Brace yourself, because we're diving into the wonderful world of libraries today. Think of libraries as your ultimate cheat sheet, shortcuts that make coding easier. So, don your programmer's hat, take a sip of that dehydrated coffee, and let's tackle the day ahead. We've got work to do, Explorer. All right, let's chat about our new piece of hardware, the 4x4 keypad. Each button, when pressed, closes a circuit and sends a signal that we can detect and utilize. It's similar to a keyboard you might use on a computer, but far less complicated. These keypads are often used in security systems, door entry systems, and all sorts of devices where manual input is necessary. Today we'll be using it as a control interface for our spaceship. The real magic happens when each button or key is pressed. A unique combination of 2 connections is made, one connection from the 4 row pins and one from the 4 column pins. This allows us to know exactly which button was pressed without needing a separate input pin for each button. Each of these 16 buttons can serve as an individual input, providing us with a wealth of potential interaction options. I can see it now. We could set a code to trigger a certain action, or assign different tasks to different keys. The possibilities are vast and are waiting to be explored. This also means we can reduce the amount of input pins needed from 16 to 8, which is important when we have limited pin real estate on our hero. But before we dive into all of that, let's get this mighty piece of machinery wired up and running, shall we? My, that was quite easy. Looks like we can skip the breadboard entirely today. Speaking of easy, let's hop on to our next coding concept and explore the power of your new partner in crime, libraries. In coding terms, a library is like a prepackaged set of code that provides specific functionality. Essentially, they give you a lot of new functions to use and make your life easier. Now, let's talk about the new library you will need to install, the Keypad library. This is a custom library designed specifically for interfacing with keypads of various sizes, like a 4x4 keypad, for example. How convenient! It includes functions for detecting when keys are pressed, which keys are pressed, and even some advanced functionality like multi-key detection. By using this keypad library, we can simplify our code and kick our level of efficiency up a notch. Because who needs more complications when you're trying to repair a spaceship, right? In order to use our library, we'll first need to install it. If my calculations are correct, there should be a link located somewhere, cached on your current computer page to a zip file. Download that to your computer, and then, in the Arduino IDE, navigate to Tools. Then, Manage Libraries. Then, Add Zip Library and select the newly downloaded zip file. Take all the time you need, preferably as quick as you can. I'll be here waiting patiently for you when you return. You finished? Wonderful! Let's continue, Explorer. The library allows us to accomplish another new practical task, and that is to create a new, unique object, a keypad. It also adds in functions like getKey to tell us which key is being pressed. In order for the newly installed library to help us, however, we need to first provide it with some relevant information. Here is our list of to-dos. We need to tell it how many rows we have, how many columns we have, the pins that we are using for our column pins, the pins that we are using for our row pins, and finally, we need to create a key map for the buttons. Whew, that was quite a mouthful. Well, We know we have 4 rows, 4 columns, and we can take a look at which pins we're using by simply looking at our wiring diagram. Next, we have to make a key map. We can achieve this by utilizing a pair of new data structures in programming, arrays. In the realm of programming, an array is a data structure that allows you to store multiple values in a single variable. Imagine it like a storage box with multiple compartments. You can put different items, or in our case, data values, in each compartment and later access them using an index. An array is defined by the type of data it can hold, like integers, floats, or characters. Once an array is declared, the type of data it can hold is fixed. You aren't able to mix integers and strings, for example. Each individual value in the array is assigned an index. In most languages, the first element in the array is indexed as 0. So, if you have an array of 5 elements, they would be indexed from 0 to 4. Let's discuss this further. Pay close attention because this is a stumbling block for many new programmers, even the best of them. Remember this like a mantra. Arrays start at 0, not 1. 0, nada, nothing. Got it? Great. Take a look at this innocent little array. Grocery list. If I ask you, what is that grocery list 1? What would you say? Here's the array for you to ponder. No, it's not milk. Remember the mantra. Milk is lounging at index 0, so at index 1, we have egg. Good. So, if our grocery list array has 3 items, what do we find at grocery list 3? Oh, don't tell me you fell for that. It was a trick question, Explorer. There's nothing there. If you were to venture so far out to index 3, you'd be rudely met with an out-of-bounds exception, a digital slap on the wrist for trying to access memory you were not given access to. So, tread lightly and count carefully with arrays. All right, Explorer, if you've gotten your head around a 1-dimensional array, let's kick it up a notch. Get ready for the 2-dimensional array. Sounds stupefying, doesn't it? Think of a 1-dimensional array as a straight line, a single row of elements. Now take that line and add more lines below it like a grid. Voila! You have a 2-dimensional array. Think of a matrix, such as a chess or checkerboard. So if you had a 2D array like this, you could access egg from Monday's list with weekly grocery list 01. Remember our mantra, arrays start at 0. Be mindful not to lose yourself in the matrix. It's all too easy to get an out-of-bounds exception if you're not careful. Stay vigilant. Now, let's take a step back and try writing up our key map. For example, in the context of our 4x4 keypad, we could have an array that looks like this. This 2-dimensional array has 4 rows and 4 columns to represent the layout of our keypad. Look similar to anything? Here's a photo of a different 4x4 keypad with equivalent functionality as ours from a small company's Adventure Kit 2 from around the same era as our Hero board was produced. Well, we're not just going to stare at our spanking new 4x4 keypad, are we? We want to see it in action. But how do we read the button presses, you ask? Time to bring out the heavy artillery, our keypad library. It's got a nifty function tucked away in its folds called GetKey. GetKey does exactly what it sounds like. It fetches the key that's been pressed. Quite ingenious, really. What do you say we cut to some instructional material that I was able to gather? Cache on the computer. I've also added this to your mission resources for future reference. You're welcome, as always.
Hello and welcome back to day 11 of the code explanations for the 30 Days Lost in Space Adventure Kit. Today we're going to be taking a look at the following new concepts, as you should hopefully have your 4x4 keypad all wired up. We're going to be looking at the new idea of what a library is. We're going to be looking at character types, and we're going to be looking at arrays, both 1-dimensional and we're actually going to jump straight to 2-dimensional for today as well. Now, I'm sure you guys already know that at the top of every single program, we have this hashtag or pound sign, include Arduino.h. We explicitly put this at the top for the reason of when we get to day 11, which is today, you guys should already be familiar with the idea of including libraries at the top. Technically, this is a weird exception because the Arduino IDE, the program that we're looking at right now, automatically includes that whether you have it at the top or not. So if you don't have it, it will automatically add it in for you. So this is kind of the weird exception. However, what happens when you want to add more libraries than that? Now, let's remember what a library is. Let's take a step back and remember what a library is. A library is essentially a bunch of extra code and functionality that you can add to your program with little to no effort. Basically, you're taking somebody else's pre-written code and functions and just adding a #include to basically get access to all the functions and cool stuff that they've already written and hopefully debugged. In this case, we need additional functionality to get our 4x4 keypad that we've just wired up today working. So in order to do that, we're going to be downloading a library called keypad.h. What keypad.h is it's a library that's used for any variety. It could be 4x4, it could be 8x8, it could be a 12x12, it could be 2x2, it doesn't matter. But the keypad library is a dynamically used library for multiple types of keypad inputs. Now, to download this, you're going to want to go to inventor.io/libraries. You're going to want to go down to the Adventure Kit section, and you're going to want to make sure you download the 4x4 keypad library, and it should install a zip file somewhere on your machine. Next, you're going to want to go to Sketch, Include Library, and you're going to click the add.zip library, and you're going to select the file that you just downloaded. After you've successfully installed that library, if you were to hit compile, hopefully you should not be seeing any errors that look like this. If you don't have the file, you would see something normally that says, fatal error, keypad.h, no such file or directory. Compilation is terminated, and it won't compile your program because it doesn't know where to find the required stuff that you said is going to be included in this .h file. So if you've downloaded it, you should be able to go Sketch, Include Library, and .zip library. And let me just select it from my downloads folder. Now I've successfully installed the library, Hero, 4x4 keypad.zip, and if I were to try this once again, you'll see it compiles with no issues whatsoever. Now, this keypad library has its own required information. If we take a look, we can actually see what the code inside of this library is doing by going to, if we highlight over it, we can see exactly where it's located. So I've now opened up the key.h file in another editor. And this is the library that is the open source library for keypad.h. The header file contains most of the information that is all more in-depth in the C++ file, but you can go and let's just jump here, for example, to the C++ file, and as you can see, it has a ton of code throughout all of here that basically grabs a whole bunch of information and gives us a whole bunch of stuff, and I don't want to go through any of this because that's the point of a library. A library is the fact that this should all hopefully be working somebody else's code that gives us additional functionality to do a whole bunch of stuff. For example, there's this getKeys function that does all this stuff, but in our code, if we want to call getKeys or we want to define a keypad, all we need to do the exact same functionality, since all this is in the code here, all we need to do is have the number of rows, the number of columns, and when we want to define the keypad, we just simply say keypad, calling from that library. We're going to call ours in this code hero keypad equals keypad, make key map with the buttons, and we're going to say the rows and columns and column pins. But we have all this in just one line versus this exact same function. If we wanted to define and make a keypad, is obviously all of this and requires a functionality from all of this here. So this is just a simple way of doing all that extra code, but just by using somebody else's pre-existing solution. Instead of reinventing the wheel, us programmers sometimes like to be lazy, and we can actually just use somebody else's solution to save time on our code. Now That means that at the top of any file where we're going to be using the keypad library or any other library, for example, we need to make sure that we include that. So that's what this is here. Include keypad.h, and we put those in. The syntax for it is to do pound include, and then the greater than sign, less than sign, and then inside we can just have the header file keypad.h, which is inside of that zip file that we've installed. Next, I want to go down and I want to talk about the rest of the requirements for the keypad library. In order to define what the keypad is and what it's going to be doing, we need to have a little bit of information. First of all, we need to know how many rows there's going to be, and we need to know how many columns there's going to be. In this case, rows and columns are both 4 because we have a 4x4 keypad. So this is pretty easy. I'm just keeping these at the top so that later on in the code, it should be hopefully very easy to add in. Next, we need to know what pins are we talking to on the hero board. Well, in this case, if you follow the wiring diagram that we have, the row pins are going to be pins 5, 4, 3, and 2. And the pins for the column are going to be 6, 7, 8, and 9. If you change up the wiring diagram in any way whatsoever, this will probably no longer work. So make sure that you follow the code and wiring diagram that we've provided very closely if you're going to be making any changes. However, let's take a step back. You probably have not seen this format before. This format is completely new, and this introduces a new concept in the programming languages. This is called an array. This is a constant array that contains the pins connected to the keypad's rows and columns. Now let's take a moment to explain what an array actually is. I want you to think of a list. In this case, let's say it's a grocery list. And this grocery list is going to be, let's have an array of length 3. So there's going to be 3 things on your grocery list that you need to pick up today. We're going to have the following: milk, eggs, and butter. So to do this, let's use the data type string grocery list. And we're going to have it be a length 3 equals, and then what are all the items we just mentioned? Eggs, milk, and butter. And then obviously go like this. Now, this is how you would make an array of length 3. An array, at the end of the day, is mostly just a list. This can be a list of anything you want. It can be strings. It can be, in this case up here, we have them being bytes. It can be integers. It can be floats. It can be objects. It can be whatever you want it to be inside of there, but they all need to be the same type. That is a requirement for a list. So you can't have, you need milk, eggs, milk, and instead of butter, you have 42. That won't work because 42 is not a string. So what you need to do is you need to make sure that they are all of the same type, like so. Now, another thing I need to mention is that arrays, even though it is of length 3, let's just say you want to find, if I were to ask a question, now grab me the 3rd element on the list. To do so, you might think, and this is a new syntax, you would do something along the lines of, you might think you want to do something like this. To get the 3rd element, you should just print the element at the index of 3, right? Nope, that is actually wrong. If you try to get the element at index of 3, you will be accessing what should have been in this spot here. But there's nothing here. So how do you do that? And why is it that way? Since arrays will always start, and us as programmers always like to start at index of 0. So if you were wanting to grab the 3rd element, it's confusing, and I know it's a little bit hard for new programmers. You'd want to grab this. If you said this would print butter. If you said 1, you would not be getting the 1st element. You'd be getting milk, which is the 2nd element. And if you said 0, because again, arrays always start at 0, this would be printing eggs. So eggs, if you wanted to print milk, if you wanted to print butter. This is how you would do so. But at the end of the day, arrays is just a data structure that allows us to keep things in a nice, organized list. And we can access what's on the list by using syntax such as that. Now that we know what an array is, at least hopefully in a little bit more detail, we can actually jump down to here where we're going to be introducing another concept called a two-dimensional array. Think of this as like a list, but it's two-dimensional. So in my opinion, I would like to think of this actually more as like a spreadsheet. If you've ever used something like Microsoft Excel or Google Sheets, let's just say you want to access row 2, column 3. Remember that everything starts at 0, so you'd go row 0, 1, 2, and then you'd want column 3, which would be 0, 1, 2, 3, and that would be this here, the character C. So the way to access data in a 2D array is actually very similar to how you would access it into a one-dimensional array. It's just that you need to also specify not only the index, but the index of the column as well. So think of it kind of like an Excel sheet, and that's how I would generally think of it, is it's a little bit easier to remember that way. Now, the reason we're doing a two-dimensional array to define what each of the buttons will stand for is because, well, as you can see, let's actually hold up, maybe you can even hold it up right to your monitor. Go ahead and hold up your keypad right to where the 4x4 2D array is on your monitor. You might notice that it lines up ever so perfectly. The top left button will be 1, then 2, then 3, then the character A. 4, 5, 6, the character B. 7, 8, 9, the character C. Star, 0, pound, and then the character D. Now, I'm sure that in the past you've seen before various things such as strings. Obviously, if you're going to use a print statement and you want to say battery level, and then print what the battery level is, battery level in double quotes being looking like this and this, string. Obviously, this is a pile, but this is what a string would look like. It would be something inside of double quotes such as that is generally how strings are represented. Now, you'll notice that these are kind of like strings, A, B, C, and D, but they're in single quotes. Now, why are they in single quotations? Well, fun fact, did you know that the data type of string is quite literally just an array of characters? And characters, or chars, is just an additional data type. So fun fact, little did you know, you've been using arrays this entire time. So for example, I just want to give you a good example of what I'm talking about here. If you say something like, and I'm just going to put this in a little comment block, string, let's just say you use a string name equals hello world. Did you know that this is quite literally just an array of characters? What the compiler will do is it will string together all of these individual characters and then compile it into an array of length. Well, in this case, the compiler will automatically do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Anytime you've ever used string, the compiler will automatically convert it. When you hit verify and compile, it would automatically convert it to an array of characters such as this. It'd be a char string name of length 12, because that's what's in here, H, comma E, comma L, ... etc. So this entire time, you've actually already been using arrays. It's just a list of what characters we're going to be using. So a character, at the end of the day, is just a much simpler form of the string, because it's obviously, instead of needing an array for a string, it's just the actual data type itself called a char. In this case, all of these values are chars. Even the 1. The 1 is not an integer, it is a character. It is a character ASCII of 1. It is not the number integer of 1. This is the ASCII character of 2. This is obviously a C. This is a ASCII of a hashtag or pound symbol, and this is the ASCII of a star. Now, the reason we're using characters is because our goal for today is to be able to print out all of these characters and to make sure that our keypad is wired up correctly. Once we have all of this information, we've made the map, we've made the bytes for the pinouts or the arrays to show what pins we're going to be using, and we've told them how many pins and columns we have, we can then finally construct our keypad. Now, this seems like a lot of work. However, given the fact that we have our library that does most of the work for us, you can actually, as you remember, it's actually not all that much work. Let's ignore all this and let's say, thank goodness we didn't have to do any of that. And we can reduce it just down to this. Now that we have this, we now have a keypad that we can call those functions from. Now we've called it Hero Keypad. Anytime we want to call a function that's included in the library, for example, we have get keys, we have scan keys, we have all these other functions. Anytime we want to call those functionalities and be able to do those things on our keypad that they allowed us to, we can do something like this. Hero keypad dot wait for key, like this, and this will call the function that was included in here to let us use on our keypad that we finally defined. However, we don't actually need to do all that much here. We only have hero keypad dot wait for key, and all this does is it just simply waits until a button is pressed. As soon as a button is pressed, it will save whatever character it read off the keypad into char pressed button. And then finally, we will serial.println whatever button we pressed. And it will print that to the serial monitor at baud rate 9600 that we've defined in setup. One last thing I want to mention is you don't have to set all of these as outputs in any way, shape, or form on here. And the reason we don't have to is because, as the library already takes care of it for us, it already has functionality to set the pin modes inside of the library, so we don't have to worry about doing it here in setup. Therefore, our setup is actually very simple and just has us start the serial.begin. Assuming you have everything wired up correctly and all is good to go, you should be able to just hit serial monitor, read off baud rate 9600, and then start pressing buttons, and hopefully you can start seeing as you go through each of the buttons, everything will be printing correctly. And with that, that's the end of the code for today. I will see you again tomorrow.
Welcome to the Day 11 wiring example video. Actually, today there really isn't any breadboard wiring at all for us to discuss. We'll just be exploring the use of our 4x4 keypad input device. And so the only wiring involves connecting it directly to the Hero input pins. The only output we'll have, at least for now, will be the characters that are sent to the serial monitor console. Now you can see here that we've connected our keypad's 8 lines. There are 4 each for 4 rows and 4 columns of buttons on our keypad. We're connecting them to the input pins on the Hero numbered 2 through 9. Now, to keep the wiring neat and organized, we've used a multi-connector or a multi-conductor ribbon cable for this purpose. And the ribbon cable has color coding that helps us to sort of keep the connections straight and keep from confusing the proper connections. Your ribbon cable might actually have different colors from these, but that's not important because what's really important is having the correct connections between the keyboard, the keypad, and the Hero pins. By the way, you might notice that my ribbon cable here just happens to have black as one of its colors. And I guess that's kind of unfortunate because we've tried as much as possible to only use black for ground connections. But in this case, it was impossible for me to include the ribbon cable without having to either use a red or a black wire as part of the signal bundle. So I just decided to go ahead and use black, in this case for pin 9, but kept in mind to remember that in this particular case, black is not a ground wire. So we've made an exception this time. Now, when we read through the software sketch for today, we see that each row and column combination for a pressed button, so we press a particular button that belongs to a row or a column, is assigned to one of 16 different output characters, which I've identified on this guide card right here for our reference. The keypad rows and columns are numbered with the origin in the upper left, so they number from upper left to lower right. So for example, the character that has the lowest numbered row and column in our sketch is the number 1, and so that should map to the upper left-hand button on our keypad. Likewise, the highest number row and column in our sketch corresponds to the character D, which we have mapped to the lower right-hand corner of our keypad, and so on. So if we've correctly wired up the keypad here, consistent with what's in our sketch, all that really remains for us to do is to load the sketch and then watch the serial monitor as we press the buttons and see that we get the output that we expect. So let's go ahead and do that. Let's move over to the IDE. Sketch is loading. And Sketch is now running. So let's go ahead now and let's say press the upper left-hand key. We get 1 as expected. Press the lower right key. We get the character D. Good. And we can go across the rows and columns. So for example, if I go across the second row, there's 4, 5, 6, B. I can go to the bottom row here, asterisk, 0, £, D, and so on. So it appears that we have correctly lined up our software sketch with the wiring of our keypad, and we're ready to go on to more difficult things. So that's pretty much all for today's task. Once you've completely understood what's going on here, then we'll be ready for the next step, and we'll connect the keypad input to other output functions in circuitry. So we'll see you then.
My, you've been busy today. Getting to grips with our 4x4 keypad is no small feat, but you've done splendidly. You're now able to read button presses with the deftness of a seasoned spacefarer. I hope you're starting to see the potential here. You are, after all, building a control system bit by bit. And this is just the beginning. Now, allow me to entice you with a hint of what's to come tomorrow. I'm running a diagnostic on... Compartment 16 is taking on water. I've got it, don't panic. I don't understand. The warning light should have been clearly visible, and you didn't pick up on it. Okay, Explorer, we can't risk another hull breach. We need to find a way to keep you aware of potential problems no matter where you're looking. I'll first aid the compartment, and you think about alerts. And now the alarm system's failed. I guess we've got our work cut out for us tomorrow.